Hey, good evening there. This is Alex Bros representing Georgia Tech. Tonight we're going to be doing a little experiment or walkthrough of the gyroscopic moment effect from propellers. I'm going to show you the contraption I made here. I wish we had some zooming out ability here, but we don't. Okay, basically this big fixed frame here, it's going to be supporting the control system. We're going to look at pitch rate. This is the aircraft we're going to be modeling and measuring for the experiment with this propeller. And it's going to be hooked up to two 9-volt batteries. And the whole thing is surrounded in this little box here that, as you can see, we can move back and forth. Now let's take a look at the measuring system. If you see, there's a black line right there on the side that's measured at 45 degrees. That's going to be the measured input for our Q, or pitch rate. So I'm going to estimate it to be about 1 Mississippi. So about 45 degrees per second input for the Q. And let's take a look at our measuring output here. What we're going to be doing is measuring the estimated yaw, however much it is. And we're feeling British today, so this is going to be counterclockwise motion instead of clockwise. So that means the yawing motion is also going to be counterclockwise. So going this way. And we're going to take our scale, engineering scale, and basically just look down here at however many degrees it's moved and measure the output. Alright, well, let's get started. Alright, propeller is on. Here we go with the input. And unfortunately not a lot of motion. We'll try it again. Oh, if you saw, we had a little bit of a bounce. Yep, slight movement there. A little bit more. Fortunately, there's not enough power there to really get full movement. Nope, we had a little bit of movement there. Kind of depends on how fast we do the pitch rate. Yep, there's a little more. See how it moves counterclockwise? And we're about to lose power, so I'm going to go ahead and cut it. Alright, and that's the gyroscopic moment effect. Well, thanks very much for watching that little demonstration. I wish we could have provided a little bit better visual of the gyroscopic moment. As you can see, we try to make this as frictionless as possible with these washers, and the real reason we didn't see that visual as good as we'd want is because of this. This was a little too heavy with motor, this type of wood used, and the batteries here, and also because this propeller and motor RPM, because it's low on battery, weren't really enough to overcome the IZZ of this entire block right here. So that math is going to be, wrote down a couple equations here. We have N is going to be equal to QI omega, which is, those two are from the propeller. You see I've made a couple of these connections. So we had good pitch rate. We had really good fast pitch rate, but we write the sum of all the y-axis moments. We have the QI omega that we're trying to model. that's negative again because we're doing it counterclockwise here. And again, that's going to be equal to IZZ times, we'll call it psi double dot, because that's the yaw angle. So this value right here, because of that weight of that block, is the reason we're not seeing that as good as we want. But you know, if you take my word for it, we did see some angles earlier that were close to about 20 degrees when we looked down here and brought a scale down and saw close to about 20 degrees. But this concludes the experiment. I hope you've enjoyed watching.